Welcome everyone to PTR's podcast. Today's theme is on the role of alternative grid technologies in the energy transition. We're going to start with the importance of the power grid and then delve into flexible AC transmission systems, also known as FACTS, and grid enhancing technologies, finishing with challenges to today's adoption and what can be done to alleviate this bottleneck. With me today are two speakers, my colleague Saqib Saeed and Peter Wells, CEO of SmartWires. To give you a little bit of background on Peter, he's accomplished in the power industry as an executive, bringing over 3 years of decades from global leadership experience in renewable energy products and services, as well as manufacturing. Peter joined SmartWires from GE Renewable Energy, where he served as the Chief Executive Officer of onshore wind for European and Sub-Saharan African regions for 2 years. During his tenure at GE, he went from 6th to 3rd in the market, doubling its volume and market reach. Peter previously held the role of Senior Vice President and COO for services and projects with Vestas Americas, where he was responsible for all projects and service operations in the US and Canada, and led integration of upwind solutions into the broader service organization, improving top-line growth and margins, establishing the Vestas repowering model for the US, and introducing new operating models with digital tools. Prior to Vestas, Peter had spent 5 years with Upwind, where he was CEO, growing the business 10x to increase the leading independent service provider in the US, before successfully selling the business to Vestas in 2015. Peter is originally from the UK and has spent time at a variety of European companies, mostly in the EPC, that would be engineering, procurement, and construction space, as a chartered surveyor dealing with commercial management of large and complex infrastructure projects. Peter has a bachelor's degree in science for quantity surveying from the Nottingham Trent University and was certified associate of the Royal Institute of Chartered Surveyors. Thank you, Peter, for joining us today.
Thanks, Mike.
So joining Peter is my colleague, Saqib Saeed, Chief Research Officer at Power Technology Research. So I don't need to go into too much detail about him because I work with him day to day, but he basically is in charge of all the research here at PTR. And of course, there's myself, CEO of Power Technology Research. Won't go into my background, but it's in finance, been in market research now for over 14 years. All right, well, jumping right into it, we got theme 1, which is the role of the power grid in energy transition. We're going to specifically look at a product comparison of non-wire alternatives to other solutions. Let me start with a basic question. Why do we need to improve the grid? Why do we need to innovate and rethink the grid structure? Peter, if you could help us out and kick us off.
Yeah, sure, Mike, I'll do my best. So look, to make it really simple, I guess if we start on that, if you think about what the grid was built for originally, it was really built around centralized power plants, and typically those power plants, of course, would be close to the demand as well. So you're really now, when you phase out fossil, phase out nuclear and other forms of fossil generation, and then you switch over to renewable. Even your renewable at a utility scale, right, is much more distributed and it's in completely different places, of course. So you're sort of dealing with a fundamentally massive shift. And I have to say to you guys, like being in energy for 30 years and over a decade in wind, it's amazing to me on reflection how little we spoke of to that. Even in my job, we often wondered about the grid connection, but there was not a lot of talk about, hey, what's going on with the grid? Like the massive paradigm shift that you're driving here is huge. And so being somebody that likes simple analogies, I always say to people, hey, imagine if somebody took the heart out of your chest and put it in your left foot and your body has to rewire. That's what we're doing. It's absolutely incredible what we're trying to achieve. And very few people are really thinking about that. So how do you do that, right? And so you said, why do we need to improve the grid? That's the fundamental reason. But of course, what's coming with that as well is there's all sorts of other issues beyond capacity and congestion. You've got like dynamic stability, the sort of reactive power of the grid, the intermittency of renewables. So you can layer and layer and layer on top of that fundamental physical shift, if you will, a lot of much more complicated engineering related issues, right, that go with the grid. And probably as well, you're dealing with 50-year plus old technology, right? That you've got to sort of sift and change. So you have to invest. Like, you've got to invest in the grid. It was probably underinvested in anyway. We see all sorts of numbers. They talk in the EU, of course, of like 30 billion a year going to 60 billion a year. So doubling down on investment. And in our view, the traditional approach to infrastructure building, the traditional legacy technology, it's not going to cut it. It's not going to get there, and we'll probably talk a little bit more about why. But we need to rethink what's needed. And the last of the point I would make is it's not just technology, right? And that's where grid enhancing technology comes in, because of how much it can do, how quickly it can do it as well. But you need market design, you need regulation, you need policy. So you need these things to all be working in conjunction to move us forward towards a grid that, frankly, at the end of the day, has to be quite different, right? It has to operate very differently because of the massive change on generation, but also the huge disruption on a demand side. And you think about the fundamental role of the grid and the operators is, how do I balance? How do I plan for that? How do I forecast that? How do I balance generation with demand? Especially when those two worlds are changing so dramatically. What's that middle piece? What does that need to be? And clearly it needs to be someone who's way more digital, way more flexible, the ability to integrate, way more resilient, right? And I would say something that can respond real time. And today, that's not what we have fundamentally. So that's sort of where I would leave it. Perhaps is like, grid has to become something different because of the energy transition. And if it doesn't, by the way, you guys probably see the reports all the time. You probably do some of them, by the way, also around how much more renewable we need. And I always think it's interesting because, like, yeah, fine. Let's talk about that. But why are we talking about the fundamental enabler, which is the grid at the end of the day?
It's a great point, Peter. And I definitely like your analogy of putting, let's say, a bit of organ transplantation going on there, adding some appendages too while you're at it, I think is what's going on. Right. Saqib, let's jump over to you. Do you have any comments to follow up on Peter's?
Yeah, I mean, Peter has really nicely summarized the problem. I mean, if you were to sort of segment the entire power sector into layers, right? The way I see it, you have power generation, then on the tail side, you have the consumption, right? So we see a lot of changes on both ends. You know, on the generation side, everything has changed from conventional to renewable. Why is it different? You know, because of the variability of renewables, you know, unpredictability. It's difficult to predict the output of renewable energy. And then also the location, right? It's very distributed in nature. It is very inverter-based technology compared to, you know, conventional power plants. So a lot has happened on the generation side. And then a lot is happening on the consumption side as well, right? So you do not have consumers anymore, you have prosumers, right? And then recent phenomena like EV charging infrastructure. Grids were not designed to have, you know, multi-megawatt loads popping up here and there in different parts of the grid. You know, we talk about 300, 400 kilowatt of chargers. You put 10 of them together, it's like already 4 or 5 megawatts, right? So yeah, the only thing that has remained neglected is the grid itself. It needs to adapt. So hence the reason for us to rethink the grid, to be able to enable, you know, the integration of renewable. That is inevitable, you know, that is going to increase in the future. And then at the same time, you know, facilitate what is happening on the consumption side as well. So the only thing that remains is how do you sort of modernize the grid infrastructure, both on the transmission side as well as on the distribution side. So hence, you know, the need for improvising and rethinking the entire network, which was designed to have very, let's say, stable, very defined generation, right? You didn't have to predict what is going to happen during the day. You know, daily variability was not a problem. And same was the case on the demand side. You didn't have, you know, peaks and valleys in your demand 30 years ago, 40 years ago when these grids were designed. So since everything has changed from then, so grid needs to adapt because of the all new factors which are impacting both generation and the consumption side.
Yeah. Mike, if I could add on to this.
Yeah, go ahead.
Just thinking about it, that I think Saqib's touching on a very interesting point as well, which we often don't talk about, which is the future proofing, right? Because I often look at it and think, wow, we know what the problems are that we face today, and we're trying to address those. But often, like, traditional approaches take a long time, and then you sort of think, wait a minute, by the time you get there in 5 years, what does this world look like then? 10 years, 15 years, 20 years? We talk about a journey to net zero by 2050. I'm like, I'm sorry, but none of us know what demands and things we're trying to deal with in 5 years. Honestly, right? It's sort of, and I think there's another shift here, which is how does the market, policymakers, regulators, system operators, even consumers and prosumers, right? How do you value future-proofing, flexibility, resilience, those kind of elements? Because if you look at what we do today, we don't really value those. We know they're a problem, but market designs don't speak to it. And so we're not really, I mean, there's some pockets, right? There's some countries that are a bit more progressive and they're really trying to incentivize, shared savings and innovation, digitalizing and things like that. But that to me is going to be a critical part of what we have to do now, is thinking about, wait, I'm going to deploy this technology now to solve this problem, but is that a good investment in the sense that, is it also flexible? So in 5 years or 10 years, I can adapt. It still has value and I can adapt and I can move on, right? And then that's something I think that we haven't learned to apply that mindset yet, right? So I think that Saqib mentioned, like, looking back, how much has changed, but you can take that same thought process, right, and apply it forward and say, yeah, but wait a minute, what are we talking about in 2030? And I think that pace of change is going to be quite interesting, right? That we'll have to deal with that ultimately.
It's a great point. I mean, one of the key messages from the IEEE event I was at earlier this year, IEEE TND, was operational planning going down to 3 years. So it's exactly that, and as a result, you need flexibility. You also mentioned prosumer. As a prosumer, I got my electric vehicle. Sign me up for that PPA, Mr. Utility. I do not think 3 years in advance on my personal needs. It's and I would doubt most prosumers are thinking like that, right? And so you have this new dynamic, especially with concepts in the U.S. like FERC Order 2222 coming in, and now those prosumers have to be part of the equation, and they're not going to give you that kind of forecast, ability, right? So it's definitely that's the dynamic, and as a result, you need that flexibility. You have no choice.
Absolutely.
Yeah. Exactly.
Great. And exactly that. I mean, a strong power grid is really critical, right, for the energy transition to be able to move power effectively. However, the grid is becoming more and more complex every day, right? As we had mentioned, and especially due to at the distribution level. So we're going to jump into our next topic here. So Peter, if you could start, in your opinion, what challenges specifically are utilities and grid operators facing, when it comes to the clean energy transition, especially the integration of renewables?
Yeah. So you said it's complex. It is, right? I think it's actually incredibly complicated, right? And getting into the grid myself probably only 2 years ago, but even, I'd been in energy for 3 decades, and then finally get to go, wait a minute, this is actually pretty complicated. And your appreciation of what it is and the function it's deployed, of course, I mean, thank God, right? Our world wouldn't be anything like what it is today without a grid, which is something we probably don't respect enough. But it is complicated. It's getting more complicated. As you said, it's not just generation. It is on the distribution side. And I think that there, of course, you've got that intimacy with the consumer, right? And a lot more people, a lot more consumers than you have on the other end. So, of course, that's probably way more disruptive. And loads coming onto distribution grids that Saqib was mentioned, that never happened before, right? That's a really different sort of world, all this electrification. On renewables in particular, it's I would say, we should talk about there a little bit about location, the intermittency of generation, inertia or reactive power, and sort of some dynamic challenges that you often see around harmonics, traveling waveforms, power oscillation, things like this. And probably as well, you've got this speed of deployment, right? At the end of the day, that speed of deployment of renewable projects, you guys see the Berkeley Lab reports, right? Of how many projects are waiting. It's astronomical, right? So there's a pace of change that the grid operator has to deal with. So it's a complicated world. We mentioned already the location. It's in different places, right? So the network has to adapt physically to deal with that. We know, of course, the intermittency, meaning renewable generation is not like the forms of power that we've had in the past. Like the wind blows when it blows and the sun shines when it shines, and that ultimately will drive, when your generation sources are coming onto the grid. So that's harder, right? To integrate that is significantly harder than carbon-based fuel sources, which you turn on when you turn them on. So it's a completely different world. These inertia or dynamic challenges as well. So you've got resonance issues to deal with. You don't, of course, have the big spinning reserve now that you have with fossil. That's an issue which you can solve, right, with reactive power, but you've got to really think about how am I solving that. And there's all sorts, like as I get more into synergy, traveling waves and all these sort of things that come subsynchronous resonance. There's all these very specific, like a whole host of these different areas that affect the resilience of the grid, basically, or even the fundamental strength of the grid. So that's something as well that the grid operators got to deal with. We know that a renewable energy project, if it gets a grid connection, probably like the pace of that deployment versus a coal plant. So I mean, it's like you can be done in like, and obviously if everything's going in your favor, you can be done in 12, 18 months, right? To do a big wind project, you're planning earlier, of course, but that speed is much faster. So again, grid operators are dealing with increasing demand for connections and a pace that they're just not used to dealing with at all. And then probably on top of that, it's an interesting world, right? You have like, take the US, you've got a federal view on how things should be done, and then a state view on how things should be done, and so on and so on. And then you get all the way down to the community. And if you're building lines and doing different things, like that's a complex world to navigate, right? Of like, how do I deal with all of these different stakeholders? And sometimes maybe those requirements don't align, right? How do I deal with that and manage that? So I think it's a lot for them to process, the what, the when, the how. And then if you layer on top of that the demand side disruption, which Saqib will probably speak to a little bit more, it is incredibly complicated. I think that my appreciation of utilities and what they do has gone up like astronomically. But I do think, and we'll talk more about it, I think, on this podcast, but they have to evolve too, right? They clearly have to evolve and change their approach. But the technology, the market design, the policy, regulation, and obviously capital infusion, all of these things are out there, but we need a clear vision and strategy, I would say, to leverage that and take advantage of it.
Well said, Saqib. Anything for you to add? Peter covered that
pretty much everything.
Anything left for you?
Yeah, I mean, if I were to sort of think from a mindset of a utility or a grid operator, right? And I have more and more renewable sort of connecting in my grid. One of the key things on my mind always would be, resource adequacy, right? I want to maintain that balance between supply and demand. And as we discussed previously, this was rather easy with conventional generation, right? It was very much easy to predict. And then same on the consumption side as well, right? You had loads of data which was reliable. Things were not changing as drastically as they're changing right now. So, your consumption predictions were also not so off. So you had a lot of data to play with. And based on that, you could take your decisions in terms of, resource adequacy. Would you be able to maintain the supply and demand balance all the time, which is one of the fundamental responsibilities of any grid operator. Now with renewables, with the factor of variability, intermittent nature of renewables, this is something which is not so easy, difficult to predict when the output of renewables is going to change. So hence, the supply demand balance becomes a challenge for me as a grid operator. The second thing that I see is network adequacy, right? Do I have enough in my network to sort of push that power to the consumption, right? DERs are sort of distributed. And so, yeah, I need to make sure as a grid operator that I have enough capacity, if you will, to sort of put that power toward the consumption centers, right? And that can be done by adding more infrastructure in my grid, right? But I have to plan for it. So that becomes a challenge for me. So I need to plan for it ahead. That what do I need to do to ensure that I get these megawatts of power generated from renewable, from this generation side to the consumption side. So I need to do something about it. So that has to be in my mid to long-term planning. This must be involved in my planning. And then there are some, let's say, immediate things that should be always on my mind as a grid operator. These are sort of sometimes referred to as vital signs of a grid, right? So voltage and frequency stability. With renewables, there is, let's say, an impact on these two factors, voltage and frequency stability. The very, very fine margins a grid operator or utility has to maintain frequency and voltage in a very defined limits, because it sort of equates to the reliability of a network, stability of a network, right? So with renewables, as I discussed earlier, that these are very power electronics or inverter based technologies, right? So there is what we call lack of inertia, right? Because conventional generation was based off of sort of moving generation sources, right? So that was adding inherent inertia into the grid. With that being gone, with a lot of renewables integrated into the grid, there has to be something done about these two factors as well, frequency and voltage stability. So these are typical, let's say, challenges any utility or grid operator would face with a lot of incoming renewables in the network.
That's great. Yeah, just to touch a little bit on Peter's point, yeah, the stack of regulatory bodies involved can sometimes be disparate in terms of what their interests are, right? And that definitely plays a factor. So you do all those studies, you find out what you need. Oh, well, we can't do it there, right?
Exactly.
Okay. Now we're going to have to figure out, some kind of hodgepodge of solutions to do it without that visibility that we had mentioned before to even have that in place. So that I think well describes, the problem at hand and the reason why things are not so easy, right, on the grid and the challenges faced there. But I'd like to now, in this last part of the first theme, talk a little bit about what solutions, right, are out there. How can we address all these problems and lack of visibility out there? And Peter, if you could kick us off here again, what kind of things should we be looking for in terms of solving these kind of problems?
Yeah, for sure. So obviously with this gets into a little bit around what SmartWires does, and there are other companies, of course, out in the space that what's often referred to as grid enhancing technologies. And there's a few different families of offerings there. I would say you've got grid topology, is often put into this bucket of GET, and that's really about how do you take really software. You're really looking at the existing topology of the grid and taking data and modeling it and trying to think, are there more efficient and effective pathways across that existing infrastructure? So really in the realm of sort of like machine learning, almost maybe AI, you know what I mean? You're sort of getting to that kind of area of quick decisions and rerouting and sort of trying to get more benefit out of what's there. It does work, but of course it can only work with what's there already, right? So it's not really fundamentally changing anything. You then got dynamic line rating or dynamic thermal rating. There's slightly different approaches to really doing the same thing, which is how do I take ambient weather conditions and when the wind is blowing across a line, that's a nice natural cooling system. And of course, as I put power down a line, it heats the line up and the line will sag, and they're always trying to manage within those spec limits of like how much power can I put down that line. So if you've got favorable weather conditions, either just the ambient temperature itself or wind, which is a cooler, right? Oh, hey, maybe my spec limits can adapt, hence the word dynamic, right? In that condition, and I can put more power down that line. And so can I get more, at the end of the day, utilization out of that line? And the only difference between DLR will have sensors out on the system, taking measurements sort of in the field. DTR is really more taking available weather data without putting sensors out there and sort of computing. So they really do the same thing, but slightly different ways of getting there. And then the third category that's often talked about is modular, advanced, or different views. Advanced power flow control. Sometimes we add the word modular. That's what we do. That's our technology. Probably the more unique thing about that is really SmartWires is the only company that has that technology. When you break it down to say modular advanced power flow control, 100% power electronic based device, it's pretty unique. It's heavily patented, and that's something again that is really, I think with all of these technologies, you're looking at the existing grid and saying, what can I add on to that capability with silicon software, the power of that, power electronics, and get better efficiency and effectiveness of my existing asset base. With the modular power flow control, we're effectively putting our devices on circuits, and really we change the impedance on lines, and we're pushing and pulling power flow. So often what you see on a circuit is, let's say there's multiple lines on the circuit. One of those lines might be the newest best line, and it has the lowest resistance. And guess what? It will take most of the power flow. And when that line hits its max point, that circuit is now at its max, right? So that's when you see issues of like wind farms getting curtailed, or solar farms saying, yeah, we're not taking your power because I'm maxed out on my circuit. Interestingly, though, you can look then at the other lines. They might be 28% utilized, or 36, or 40, so the overall, there's capacity still in that circuit, but I'm limited, right? I'm limited by one line. We put our devices on and we say, let's change the resistance on that line, increase it, we push the power flow off. And we can do the opposite, right, on the other lines, right? We can actually reduce the impedance. That's then most of the modeling and the project deployments we've done, you're then getting to say more in that 90 to 100% range on all of the lines. And guess what happens? Like we did a project last year with National Grid. We put 43 devices on 3 circuits, 5 different locations. We added 1.5 gigawatts of capacity, and that was a 12-month project. Like 1.5 gigawatts, that's a decent number of wind farms right there. Do you know what I mean? And so that's right. So now you're saying, wait a minute, I didn't have to build new lines. I put these devices. We can put them anywhere, but typically they'll go in substations because you've got the space. I don't need permitting. They're 5 meters by 2.5 meters on footprint, right? 2.5 meters high. So they're in the world of transmission, they're pretty compact. You're not going to put one in your house, but in the world of transmission, they're pretty compact. And we'll deploy multiple units, of course, depending on how much power we're trying to move around. But that, doing that within your existing footprint, you're playing with the efficiency and effectiveness, utilization, optimization of your assets. And that was, in the UK, of course, you've got lots of renewable energy in Scotland, onshore wind, offshore wind, but all the demand is in the south. And so they have a bunch of bottlenecks on the existing system that, how do I get this renewable power down? And I can't. And in the way the grid's designed today, traditional solutions, reconductor lines, build new lines, maybe do some PSTs or things like that, but they take a lot of time. Even if you then get the approval to do it, right? So that's the other sort of equation there. The other thing I would say with this, what I think is interesting with GET in general, I think there's that flexibility that I talked about as well, right? Because if you think about the modularity of advanced power flow control, that says, I'll put these devices here now because I've modeled that with the customer. But like just what happened last year, actually, with National Grid, is a coal plant was phased out earlier than anticipated. And they went, oh, actually, that's changed the loading on these circuits. We'd actually like to move 6 smart valves from this location to another location. And we did it in 5 weeks. Again, that's sort of an unheard of adaptation. So I think you've got within that grid enhancing technology family, people talk about superconductors as well, by the way, maybe not. But I think to me, anything that's modernizing and digitalizing the grid can sort of sit in that bucket. And it's all about how do I move faster, deliver more with a lower investment, do you know what I mean? And actually utilize what I've got at a faster rate. It's not going to take away the need to invest in the grid in general, right? And that's sort of the last point I'd make is that I've found interesting in this job that when you look at GET and you look at what we do, it's interesting how complementary it is. Do you know what I mean? So we're very complementary to topology and DLR and DTR.
Yep.
And we're actually quite complementary to even reconductoring and new lines, because even when I make those investments, doesn't mean that now that grid's suddenly more efficient or more effective. Not at all, right? I still have value to tap into to get more out of those investments. So I think the way I tend to position GET is like, hey, it's really about moving faster, helping with energy transition, but that flexibility and future-proofing, complementing all investments to get yourself to a point where you've got a more digital platform at the end of the day, right? So to me, it's like so essential and critical that we're pushing GET more, because frankly, I think it's a little bit like what Tesla did to EVs. Do you know what I mean? It's like we need that dialogue, and we need that innovation and investment and technology in that space, because I think the power of what GET can do on energy transition on a broader level is massive. Right? I would say in my career, I've never felt I've been in a space that's like, wait a minute, this is hugely important, and we need more people to understand this, and we need more people investing in technology and coming up with ideas, because the pace and the scale of the opportunity is massive, right? So there's plenty for all of us to do. We just need to move faster, as I said, at the end of the day. So yeah, there are solutions. I think GET is a really, really major part of that.
Yeah. Just a little add on there. I mean, in terms of, as you mentioned, right, we're not adding things to the grid. We're also taking things down. Here in Germany, we're taking down nuclear, potentially putting coal back on for a bit here. Separate story. We'll but the point is, things are also coming down, and it's dynamic. And as a utility or potentially approving as a regulator of what's going on, you're kind of forced to act quickly, right? In this kind of environment, typically things have very long lead times, as you had indicated as well. So these kind of two constraints can't work. The nice thing about your technology is that can buy you time to make that decision as well, right?
Yeah.
Hey, you don't have to be forced to solve it. Get these things to buy you the time that you need to then decide, is this a temporal thing or is this a permanent thing as well, right? So I think that's a pretty important aspect that also gets overlooked. Is it doesn't we just need to maybe solve things for seasons, right? Or maybe there's we always talk about low frequency, high impact events and that kind of dynamic happening. It could also be just a high frequency, low impact event, but you kind of need that occasional solution to do that. That's not so expensive, that can then be deployed elsewhere, right? So you're not sinking an investment in something and then stuck with that particular solution on maybe a circuit that doesn't need it, in the next couple of years.
Yeah, which is the challenge sometimes with some of the more traditional devices, like a phase shift and transformer will do its job. But it's going to take a lot longer to design it, because you're trying to think through every possible thing it may have to deal with in the future years. So you're trying to design in all of this capability set. It's way bigger, right? On a footprint, it's going to be 70 meters by 57, like it's big, right? It's going to be a big installation. It's not going anywhere.
Yeah.
Do you know what I mean? Like once it's done, it's done. That's it. That's like, it's not going anywhere.
Exactly. So and even at the end of the day, it may be the right solution, right? But it can be very complementary, right, to your technologies.
We've modeled even the application of smart valves with PSTs, because they can actually do slightly different things. And some of that quicker, let's say power flow control that you may want, that's sometimes better with a smart valve because it's power electronics, right? So you can handle that really easily and not wearing anything out. But if you cycle a PST a lot, you're changing its use case, and you can shorten its life, right? So that can change those investment characteristics as well. So yeah, it's incredibly complementary. I would say, I think it's important that people don't consider grid enhancing technology as a band-aid, though, because yes, I completely agree. It absolutely will solve things faster. But at the end of the day, if you think about what it does, it's, hey, I'm getting better data, right? I'm optimizing the utilization of my asset, right? I'm giving myself real-time control that I've never had, and variability of that, like a tremendous like control and variability of what I do in terms of how I push and pull power flow across my grid. Like, why wouldn't I do that anyway?
Yeah.
I mean, that makes all the sense in the world. So yeah, I think it's critical that people look at it as yes, I can move fast, solve problems, and it's super important we do that. But it's not like, oh, I just needed it for a few years, now I don't. It's like, no, you've actually then used it to move towards a digital grid that makes all the sense in the world. Like, why would you never do that? Why would you never do that? Maybe it's because market designs don't incentivize that enough. Do you know what I mean? That's part of the problem here.
Yeah, it's I think that's a great point. And it also touches on that visibility aspect, right? So we talked about kind of the shortening of the operational planning cycle, and it's now encroaching on what we were just talking about with maybe only thinking about in a tactical manner as a band-aid, as you mentioned, the visibility isn't really forecasted to improve. If anything, it's going to get worse too. So I think in the merging of like what was formerly considered strategic planning with tactical, that coming together, why can't a solution be great for both, right? I think that's a good point. I wanted to quickly to ask Saqib, anything to add on these kind of solutions? We did go over quite a bit. But,
yeah. I mean, every time we talk about technologies which can support the grid infrastructure in, let's say, achieving higher percentage of renewables, I always go back to an assessment that was done on the US grid. It was back in 2016. And the outcome of that assessment was that since the US grid is already, it is aging, it has more than 70% of transmission lines operating, beyond or close to end of life. Same is true for transformers, large power transformers, which are super critical for the power grid, pretty much the building blocks of the entire network. And the outcome of the study was, if you were to replace the entire thing, if you were to modernize the entire grid and have everything replaced which is close or beyond end of life, pretty much you need more than $1 trillion to achieve that. And also to be able to cope with the expected incoming renewable generation, right? And the whole idea of GET's flexible AC transmission devices is that what can you achieve with the existing infrastructure without, having to add more transmission lines, more transformers. That's always a solution that I can always do as a grid operator, right? But what can we do with the existing infrastructure? Which technologies can support us? And I think GETs, of course, we talked about this in detail. I'd like to talk a little bit about the DC grid as well as a potential, solution to many problems which might or already are occurring because of higher percentage or share of renewables. HVDC, we have seen that how this technology has evolved over the year, especially the voltage source converter technology, right? So the ability to be able to shift the power flow very, very quickly. One region can support the other one in case of, any let's say lack of generation supply demand, let's say imbalance. HVDC has been very successful technology, and now with this sort of trickling down towards the medium voltage level, I think that's also very promising. And then finally, storage. I think it's also an important solution to many problems for utilities when it comes to renewables, all the problems that we discussed earlier, right? Resource adequacy, network adequacy, peak shaving, for example, matching your demand and supply. Storage plays an important role, and I think there have been great advancements when it comes to storage technology. You talked about National Grid, Peter. I think a lot of projects have already been installed by National Grid, and it's a technology which is supporting the national grid operator of the UK to be able to, let's say, achieve their targets for renewable. So I think GETs, storage technologies, DC grid, I think all of that combined, these technologies are a must-have for the grid operators to ensure that they're on the path in terms of their renewable adoption.
Great, Saqib. Thanks for that point. Certainly storage solutions do play a role in that solving of problems on the grid. I think also it's within the context of where it makes sense to do that, and that it aligns nicely then with where utilities have planned things. So I think that's I guess the little caveat there in terms of you got to make sure you're putting it in the right place when you're doing those things. But let's cognizant a bit of our time. Let's jump into the second theme. And I'll caveat this that I'm the finance guy, but Peter was talking about topology-based solutions, and when I hear topology-based solutions, I'm thinking, okay, this may be a type of software solution as well. It could be based on that kind of methodology. So theme 2 is about, and we talked a lot about hardware, but I want to talk a little bit about software as well. And I want to know kind of the interplay and the roles between the two. Over the last few years, heard a lot about things like DERMS technologies and these platforms, if you will, right? I want to hear. Let's start with you, Saqib. Your thoughts on platforms like DERMS or things like concepts like virtual power plants, right? And how do you think that they're able to solve problems like renewable energy integration or things like congestion, lack of inertia? Like are they able to solve these issues? And in what way do you see them doing that?
Like the way I see software solutions, I think the way forward is that both hardware and software solutions will go hand in hand in solving all the problems. Not one, let's say, approach can solve all the issues that you might face with the increasing share of renewables. I think we have proven use cases of DERMS and virtual power plants that it is something which is viable. It lets you address some of the problems that we discussed earlier on the consumption side, right? You can change or let's say impact the load profile based on the demand response. So that's something that's already there. But I think there is still some, let's say, lack of focus on the hardware side, especially when it comes to some of the core technologies of grid, right? So you talk about transformers, transmission lines, cables, grid enhancement technologies. All of those, I think, especially the main building blocks, they have been neglected over the years. There is a lot of room for improvement, I think, when it comes to the core hardware technologies. Just look at inside the transmission substation, right? There's a lot of room for improvement. Let's talk about the most important, most crucial piece of equipment, that is large power transformers. And Peter talked about flexibility, right? So achieving flexibility in the solutions that you're deploying, that has been an issue with large power transformers. They're very, very custom designed, right? So only for your solution. So having not a lot of flexibility in terms of your design has been a problem for large power transformers. A lot of room for improvement when it comes to the core of transformers, right? Focus has been on achieving higher efficiency when it comes to transformers. But I think from the raw materials perspective, core and winding, more can be achieved on these technologies as well. And then same is true for transmission lines, cables. I think hardware itself, perhaps the core hardware for the grid has been neglected. Of course, software solutions are going to be extremely important for us to be able to achieve our plans to have certain share of renewables by 2050 or 2030, long and midterm plans. But I think both hardware and software solutions will go hand in hand. We talked about flexible AC transmission systems, right? The response time has been a big question, right? That how quickly are you able to address any congestion problem in the grid? The upcoming technologies sort of addressing that. We talked about prosumers on the distribution grid side, right? So that means that the grid is not unidirectional anymore, right? So you have sort of multi or bidirectional flow of power. Distribution transformers can be augmented with power electronic solutions, for example, right? So a lot can be done on that side as well to be able to achieve sort of more control, more flexibility, and bidirectionality when it comes to power flow on the distribution side. So I think there is a lot of room for improvement. Hardware can be improved both on the transmission and distribution side. And then, of course, software will support that. There is a lot of push when it comes to digital solutions. Again, let's take example of transformers. There's been a lot of push towards digital transformers. I think that is a great, let's say, theme when it comes to controllability in the grid, because you have millions of distribution transformers spread across the grid, right? So there can be your eyes and ears for the grid if you have enough data collected from the transformers. But yeah, I think both on software and hardware side, things will go hand in hand in order for us to be able to address all the issues with a higher share of renewables in the future.
Great point. Peter, anything to add here?
I agree, Saqib. It's obviously you need both hardware and software. It's one of the things I've done a little bit is I've sort of I worked briefly in telecoms like late 90s, and I always think it's interesting when you think about how radically that market evolved and changed. And it's funny, like when you look back, you feel like it changed so quickly too. But actually, when you really look at it and you sort of say, yeah, telecoms today in terms of what that market is massively different to what it was 20 years ago, let's say. But then you ask why. Fiber, cellular networks, right? The internet, APIs, deregulation. There was a bunch of pretty instrumental disruptive forces, right? Either market design or regulation or technology itself. When you look at the technology, it absolutely was both hardware and software. So Saqib's, I think, exactly right. And I think our world I don't think the grid will quite evolve in the same way as, let's say, telecoms and that world did, because I think there are some limitations, right? There isn't a what's the cellular equivalent that we have, so that's a little tougher, right? But I think there is stuff there, right? And I think things like DERMS, that at the end of the day, you're really looking at advanced algorithms. That's what GET really is, to your point, Mike, as well. They're embedded in the smart valve that we have there. They're part of DLR. They're part, they're really looking at how you move very quickly and fast in terms of reaction to things happening on the grid, and you don't have brownouts, blackouts, or problems like that. I do think in the end, the piece that maybe that we're lacking, I think, as an industry, is that vision of like, where are we going? Like, okay, so fine. How do all these pieces come together? Because like they're all great, right? At the end of the day, and Saqib said it. You need all of it, right? Not one thing like storage or anything is the panacea to everything. It's just not. You need it to be integrated. And so what's that look like? What's the vision of where we're going with this innovation? Are we really incentivizing and stimulating that, and encouraging that to happen in a way that perhaps, just think even the evolution of APIs and the internet, what a whole completely new economy that didn't even exist like 20 years ago. It's mind blowing, right? So how do we get there? I think is a really good question. I often speak to people about it. I hear more and more people talking about it. I've sort of come down to the conclusion of like, we'll take this innovative hardware and software in the form of applications. And I think our first phase is we're in it now. And if you think about it, we're really applying that technology, whether it's a virtual power plant or storage or a modular power flow control that we have, you're applying it in a very transactional way to solve a problem. Do you know what I mean? Like, I have this problem, let's model the application of the technology, solve the problem, deliver the project, done. Right? That's a pretty transactional approach. But of course, those applications are super important. DLR, DT, that's all an application-based sort of approach, right? But then you sort of say, hey, wait a minute, that next phase then probably is the service phase, right? Because as you get that distributed base of technology, all of it, right? I'm not talking about one, but all of that stuff's out there. Now you can realize very quickly, wait a minute, the ability of what the operator can do is going to change. Like, quite clearly that's going to change. So what sits now on top of that technology in terms of the advanced algorithms, the modeling, right? Predicting, dealing with flexibility, integrating new assets faster, right? Resilience, things like that. That's never going to be a human operator, right? Let's be clear. That's going to be technology that's like there and moving like super fast. And in the end, I think I was at a conference and actually, as Dr. Michael Pesson said, the grid needs to become more like the internet. And I was thinking, wow, that's interesting, right? And I'm like, yeah, I tend to think of it like platform, but you combine the two, it's sort of like, yeah, it needs to become some kind of energy net where it really is a sort of end-to-end seamless and holistic solution, and a system that says I can adapt and unleash all of this innovation. Bring it on. You want this wind park over there? Great, done. Right? You want to add more distributed EV chargers? Done. Make those batteries available to us, though. We might use some of your power occasionally. Do you know what I mean? It's like all of that innovation and thinking is out there and can be, I think, used if the grid is something different. And that's the really fascinating part, I think, for us, is like, wow, what does that look like? And it isn't just about climate at the end of the day. I think that you sort of look at it and say, yes, it puts us on the path to a net zero world, but this is a whole new green economy. So I mean, like, think about the stuff that goes on the basis of the internet and how telecoms has evolved. that I think there is real potential for that as well. So we need the hardware, we need the software, and we need that vision of where we're going. And really, at the end of the day, economic growth, better, more security around energy systems, more sustainability. It all just layers on top for me, and that's actually pretty exciting. So anytime you see anything like DERMS or I think it's really exciting, right? I love it when you see that stuff. Oh, that's really cool. How do we integrate that more, right? How do we utilize that more? I think that's the question we should always ask ourselves.
Yeah, really great points, Peter. The term I always think about is the business models that need to be driving this, right? I think concepts like utilization of assets and things like that needs to permeate more into the grid, just like how it's done with generation, right? And I think those concepts and the business models associated with those concepts, yeah, that's what really needs to be kind of injected, pun intended, into the kind of the grid model, if you will. Great. So let's move on to our third theme, and it'll be the final theme of today. So to conclude our discussion, I wanted to focus a little bit on the technology adoption, right, in the power grid today. Utility sector, if you will, has been called conservative, and I don't think I'm going there out on a limb to say that. However, I can understand a little bit about their sentiment, right, and where it comes from. And this is because you have both the ensuring and security of supply, that requirement, as well as you could say a traditional process, right, embedded in regulatory frameworks by which they operate, right? So you got those kind of dual things happening. However, regardless of how it's currently set up, we're in the middle of a huge transition, right, as the world moves towards cleaner electricity, and obviously innovative solutions are needed to keep up with this pace of change. So I'd like to start with you, Peter, and around the theme of what do you think can be done to mitigate this kind of reluctance to adopting these new technologies?
Yeah, I think you put it well, Mike. I think they are in a bit of a tough spot, right? Because there are, there's requirements on them from regulators, right? They're regulated and they have to provide safe, reliable, low-cost power to the consumer, which is increasingly green, as we talked about. And that's a pretty tough world to be in. And I think when you think about new technology, of course, that's introducing risk, right? So that ability to drive technology assurance, if you will, which is something we talk about a lot, is like, what's your technology assurance program and how do you engage with that with your customer? And in the end, I think to a large degree, I would say there is a requirement for patience and process at the end of the day. That just is. But I would also say there needs to be a few other things, I think, which is a commitment to say, I want to get into this and understand it, because ultimately adding the technology will benefit everybody. Like it just does. And it benefits everybody, whether you're at the consumer end or the generator end or in the middle. This technology will help everybody at the end of the day. So I think that commitment to saying we need to understand this and figure this out is really important. There is, I think, therefore a sort of a need on the utility leaders, frankly, to sort of take that on, because yes, they're in a tough spot and they have a job to do, but there is also this cultural element, and I think sometimes cultures live beyond the essence of what they're trying to do. And so it's interesting, and I would say I look at our world and where we work in Europe and Australia and South America, and I've got, like, I could give you a list of a dozen customers that have been very progressive, right? And with every single one, there's really two things going on. There's a leader that has tasked his team to say, I mean, and I often say, I think the culture of the engineer often in the utility they're the no engineer. Their job is to find as many ways to say no as possible, almost, right? But what you always see when the things are going the other way is that a leader, whether it's in engineering or on the technology side or the operations side or somewhere in an organization with influence, has said, go find yes. Tell me how I say yes. And you have to do the same thing, but they're flipping really on its head and making the mindset different. And whenever that happens, we see different outcomes in terms of pace of change and adoption. And then the other thing is that we always see there's something going on in that market, whether it's shared savings like you see with the RIA framework in the UK, or whether it's transparency like you see with the RIT process like in Australia, or whether it's sort of a competitive market, right, that you see in South America where the system operator has to compete to get the work. So if I have to compete and I've got absolute transparency and shared savings, guess what? I want the technology that lets me move the fastest with the biggest impact for the lowest cost. Right. So that fundamentally just drives really, I think that mindset shift and the ability and the desire to change. And so, yeah, we see examples where it's working well. And I think in the end, like that's what I tend to talk about with my team around technology adoption and the sort of the conservative nature of the industry is like, it is what it is, except that it's there for a reason. So how do we facilitate that change? And we know the things that, hey, look what these guys did, what was going on there. How do you take that? How do you take all these elements of market design, cultural shift, leadership, and sort of say, okay, look, there's half a dozen things that really make a difference. Let's go work on that with these other markets and these other customers. So there is a way to get there, but I think, yes, we have to be a bit patient, but then, and it has to be a good process. But I think that commitment and making sure that we're educating the broader market, guys, there is a way. There's absolutely a way to do this and to move at really the pace we need to, without taking risk. You're not taking risk. I mean, you take a smart valve, that's a fail-safe device. Do you know what I mean? Like if something happens with that device, the grid will not go down. It's bypassed. Do you know what I mean? So there's ways that you can do it. Say at the end of the day, even in worst case scenario, I've taken no risk whatsoever. All I have is upside. Right. So I think there's a way to get there, but I think we just have to understand it and educate and sort of find ways to be progressive and move forward.
Yeah, great point. Like kind of a bit of a culture of education. And just a small anecdote with those electrical engineers, we work with a lot of them ourselves, and for us, it's to get them comfortable making a forecast, right? Because that requires assumptions, and how do you get that mentality, to be kind of changed and comfortable with that? I think just at a higher level, comfortable with, like, hey, let's go back and let's learn about these new technologies that maybe we didn't learn about in school that we haven't used before. Let's do that, right? And I think that's exactly what I think is one of the biggest challenges. Saqib, anything to add around this technology adoption?
I'll add a little bit on top of the last point that Peter mentioned. That's education. I think that plays a very important role when it comes to, let's say, having enough justification to have a new technology, a rollout of a new technology in your entire grid. Because from a utilities perspective, the primary job is to ensure, reliable supply of electricity and ensure that that they're not putting the grid in jeopardy, right? So hence that's where the conservative nature comes in, right? Sort of a reluctance to adopting new technologies. And I'll draw an analogy of GETs and then sort of adopting new technologies to have, let's say, less issues like congestion in the grid. Similar kind of things happen on the equipment side as well, right? So an example of that would be switchgear. We all know that on the switchgear side, we have different technologies. One is called the SF6 technology, gas insulated switchgear, right? And SF6 is a very potent greenhouse gas, right? So there's been a lot of movement. In fact, in EU, it's already been banned for one certain type of switchgear. You cannot, from a certain point in future, you cannot install SF6 based switchgear because it's such a potent greenhouse gas. And we did some interviews with utilities, and what we realized was that one of the biggest, let's say, factors in terms of reluctance to adopting SF6 alternatives was because the only thing that they had on mind was, it is expensive. Upfront cost is higher. But what about total cost of ownership? In the grand scheme of things, is it going to save you money or not? Have you factored in the amount of maintenance that you're going to do on your switchgear? It is going to be quite less on SF6 alternative based switchgear, right? Have you considered that? And in terms of the when a switchgear the time of retirement comes in of this equipment, right? So you have to be very careful if it is SF6 switchgear, because you have to have a third party, come in and then take all the gas in, so that you're not releasing this greenhouse gas into the environment. You don't have to do that with alternative technology, right? So then when you factor all those things in, okay, yes, upfront higher cost does make sense for me, right? So that's what we realized, that education on certain let's say elements such as the total cost of ownership was very important, actually showing that this is something which is in the long run is going to save money for you, because at the end of the day, anybody who is in the strategic decision-making position in a utility, they are running a business, right? The job is to, of course, maintain reliable grid, but at the same time, ensure that everything is done with a very, let's say, in a very cost-effective manner, right? So once we give that picture to the utilities, that in the long run, this is something which is going to make financial sense for you as well, then I think this reluctance goes away to some extent.
Great. Thanks for that, Saqib. Great. So now we've completed our topics for the day, and I think there were some really great points in and around the complexities, right? That we're facing the grid, the myriad of solutions that don't necessarily have to be adversarial; they could be very complementary to each other. And then some of the key things that we need to be cognizant of in terms of just general adoption, and specifically around the willingness, if you will, to be educated around new technologies, as well as maybe some slightly different metrics, not just that upfront price that may be associated with those technologies. So now to conclude, I'd like to go to each one of you, and if you could kind of summarize what are the key things that you think we need to be either talking about, thinking about, working on to try to solve and cope with this energy transition. So Peter, I'd like to start with you.
Yeah, well, Mike, I think one of the things we were talking about was, are we moving fast enough, right, to deliver the pace of change that we need? And it's a horrible to give this answer, honestly, but the answer is no, right? And I think we all see that. And I would go a little step further. I often say to people, not a chance. Like the type of numbers that you can see out there on where renewable generation needs to be, and you think about the emergence of EVs, e-mobility, electrification, all the things that need to happen for that to become real, we're not close. We're not even close, right? So that's that's, I would say, it hurts to say it. It really hurts to say it. It's something that you feel when you're in a position where you can see answers, you end up feeling quite frustrated, right? Deeply concerned, for one thing, right? Just as a human being, deeply concerned about where we are and what's going on. And then obviously frustrated because you think, we know how to do this. Like we do know how to do this. So on the flip side of that, I do have hope, because there are solutions out there, and more, I think even what we're talking about today around the grid, more and more mainstream discussion. I mean, the day that John Oliver is doing a piece on the grid, you go, okay, interesting, right? This is getting more mainstream. The Economist has been doing a lot of work on this as well. So that's awesome. And I love seeing that. I think we've got to keep pushing and trying to unify around a vision of where we think the grid will ultimately go. And I think that would be a really powerful thing for people to come together on. We need leadership and commitment to that. We talked about the education piece. We definitely need more education. There's I think there's an interesting role that the consumer or prosumer will take, right? I think that education, when you get to that part of the economy, there's a voice there that can be very loud, and that's an untapped resource today, in my mind. That how do we get that awareness higher and just get to a point where the consumer is just flat out demanding the change that we know we can deliver, and just be saying it's not good enough, guys. We need to reimagine the grid. Let's go, right? We know what technologies are out there, so how do we create the right environment, market designs, regulations, business models that will push things in the right direction, that ultimately take us through this energy transition, which I just see so many layers of goodness, right? Economic growth, national security, do you know what I mean? Net zero. You just call it out. You could like write a list of all the things you'd like to see happen, and you could probably check every box if we do this properly. So yes, frustrated, concerned, we're not moving quick enough. There are ways for us to get there. I'm hopeful, of course, that we'll turn the corner and move forward, let's say in a smart way and at the pace that we need. And ultimately, let's hope we can be, how do I put this? Let's hope we can be more visionary and good stewards at the end of the day.
Great. Thanks a lot, Peter. Saqib.
Oh, yeah, I think, Peter, you have actually summarized it perfectly. I think one of the things that all the decision makers need to ensure that it's moving forward, reactive approach might not be enough. It has to be proactive. Planning ahead would be needed. We already see that some utilities, especially in Europe, there are facing some hurdles because perhaps they did not expect the rate of electrification in the transport sector to be that high, for example, right? So there are already hurdles in terms of deploying EV charging infrastructure. That is going to impact the growth of EVs. Then that means, yeah, it is a chicken and egg problem, that one is becoming a hurdle for the other one. So that means that planning ahead and also looking at the entire ecosystem would be needed. And then ensuring that the rate of, let's say, adding new technologies to be able to cope with every change that's happening at every, let's say, node of the grid, that would be required. It's not only electrification in the transport sector, in the road transport sector, it's beyond that, right? So we have electrification in the maritime industry now, right? So utilities have to ensure that they have ample capacity, enough capacity to be able to supply to those large installation of shore electrification, for example. So they have to factor all of these things in their planning, and then reassess. And I think the rate at which the new technologies are being deployed, it must increase in order to fulfill all the targets which have been set in terms of renewable penetration, in terms of electrification of the transport sector, maritime industry, now hydrogen as a vector as well. To achieve all those targets, it has to go up.
It's really great. Well, thank you guys so much for joining us today and having this discussion. It was really fascinating and very insightful, I have to say. So with that said, we'll be concluding our discussion. So thanks again to you both for joining us. And everyone have a nice day.
Thanks, Mark. It's a pleasure. Saqib, thank you.
Thank you so much.
Take care.